it's guaranteed on the exam that you are going to have a series question as one of your 6 free response questions. It's happened basically every year. It's as certain in life as death and taxes. And with this series question, it is very likely that they're going to ask you to write the general term of a series. All right. In other words, the the a sub n that goes after your sigma. What's the general term of the series? All right. And there's potential to have a lot of different types of functions inside your general term depending on the series. So we want to get used to being able to write those series. And if we can start with series that are a little more simpler, which are the ones behind me, then I think it will help you as we get to our more complex series and the functions that are inside of them. So if we look at this, this question of how do we do that? Well, basically, we know that our input, if you will, is n, and n is going to have a starting value. And the question is, how do we use that n? How do we manipulate that n to produce the various terms of the sequence that's being added up? All right. So again, how you go about this, you may see what's going on right away, and that's great. And if not, one way that you can do it is basically to line up your values of n with the terms. Right? What you got to be careful with is what value is n starting with. Now, notice in this first example, n starting at 0. Second example, n starting at 1. So just watch out depending on the particular problem. So n's going to start. So when n is 0, we get 1. When n is 1, we get a third. When n is 2, we get a ninth. When n is 3, we get a 27th. When n is 4, we get 1/81st, so on and so forth. So the question now becomes, all right, well, how can we get from the orange n's to the, which are the inputs, to the blue outputs? All right, what do we need to do? Now, with this first example, my guess is that you've already looked at those terms and said, oh, you know what, we're multiplying the denominator by 3 each time. All right, the numerator is not changing, just multiplying the denominator by 3. All right, so one way to look at that is we're multiplying by a third, since the 3 is in the denominator. All right, we always multiply by a third. Okay, so that means that we're going to have 1/3. We're looking at some kind of geometric sequence, geometric series. All right, so we have the 1/3. The question is, what's going to go up here in the exponent? What expression involving n is going to get us what we want? All right, well, n starts at 0, and we have to the 0. When n is 0, we get 1. All right, so it would seem to be that if we have n up in the exponent, let's see if that works out, because now we have 1/3 to the 0 power is 1. All right, then n bumps up to 1. 1/3 to the first is 1/3. Then n bumps up to 2. 1/3 squared gives us a ninth. Right? So this does seem to work. 1/3 cubed gives us a 27th. 1/3 to the fourth gives us 1/81. So that expression right there, that is our general term. That's our a sub n for this first example. For the second example, we see the alternating harmonic. All right. So now let's line up our values of n again underneath. We do see that n is equal to 1 for starters. All right. So this time I'm not going to start at 0, but instead I'm going to have 1, 2, 3, 4, 5. And this shows rather nicely. Okay, we can see right here that this is just 1 over n, 1 over n, 1 over n. All right, so we have the 1 over n. That's definitely a part of our general term. But we do have the alternating, right? So that means that we're going to have the -1 to a certain exponent out front or afterwards. Usually it's written out front though. Okay, now here's where we got to be careful. All right, what should the exponent be? It's going to involve n, but is it n? Is it n minus 1? Is it n plus 1? What's going to happen? All right, we want our first term to be positive. So I don't think we want just n right there, all right? Because if n is 1, then we're going to have -1 to the first, and that would be a negative value, and we want a positive value. Right? So we're going to probably need to either add 1 or subtract 1 from n in our exponent in order to make the term positive. So we can do n plus 1 in our exponent. So now this becomes, when n is 1, we have -1 squared, which is 1, times 1. Gives us what we want, right? Let's see if it works with 2. When n is 2, we have -1 to the third, which is negative, times a half. Negative a half. So that's working as well, and the remaining terms are going to work too. All right. Now you may have written down negative 1 to the n plus 1. Your neighbor may have written down negative 1 to the n minus 1. I think that would be okay. All right. Because if we had n minus 1 right here, again, going back, our first term is 1. So we have negative 1 to the 1 minus 1, or 0 power. Negative 1 to the 0 power is just 1. So that would work out and give us the 1 that we're looking for. All right. So again, there are multiple ways to write these general terms. All right. Because the other thing too is there's no rule that says that you have to start with 0 or 1. All right. Most of the series do start with 0, 1, but it doesn't have to. You can start at any number that allows the series to work out. Okay? And the general term can be manipulated based off of the starting value, as you're going to see in a couple of examples. All right, last but not least, we have n here. It's starting at 0, so we have this. All right, and it does look like we are multiplying by a tenth, right? We have 5, and then we're multiplying by a tenth, and then by a tenth again, and a tenth again, and a tenth again. All right, so it looks like we have that 1/10 is going to be to some exponent. We just need the 5 as so out front. Let's see, we have n starting at 0. So this looks like, all right, we only want 5 when n is 0, so that would be 5 times a tenth to the 0 power. So it looks like we just want n in our exponent again. And again, this is just one way to write the general term. You may look at this and say, you know what, I'm going to write this as 5 over 10 to the nth power. That would be correct. Okay. What would not work out is if you had 5 over 10, if you had that quantity to the nth power, because now it's not a tenth to the nth power, it's a half to the nth power. So you do there. I mean, depending on where your parentheses are or what your starting value is, it could slightly alter things in an incorrect manner. But there are multiple ways to correctly write the general term of a series.